Maclaurin series and the cosine of x. Now we all know what the cosine of x looks like on a function, but very few of us know how they turn this series into a function. For example, let's see if we can find someone. Ah, yes, my sister. Hey, Kristen, which one of these is cosine of x?
Obviously the red one.
Correct, you are. Now, do you know how to find it?
I don't know. No, you tell me.
Alright, I will. So you want to turn cosine of x into a function, do you? Well, it's easy. Just use the Maclaurin series equation, which is f of n of 0 times x to the n all over n factorial. So all we really need to find is the derivatives of the equation that we want, which in this case is cosine of x. So first we set up a table. You know what? This window's not big enough. Let's go find a larger one. Ah, yes, perfect. Just the size that I need. So here's our table. On this side, we're going to find the derivatives of cosine of x all the way to the 8th derivative. So f x equals cosine of x, f prime of x equals negative sine of x. So we have our derivatives. Now on this side, we're going to find out where these the value of these derivatives when they equal 0. Zero equals 1. It's 1. So here's our table. Our derivatives and their values at 0. Say hello, Charlie. Sit if you understand. Good job. So back to the Maclaurin series equation. F of n to the 0, x to the n over n factorial. So now that we have all the derivatives and where they are at 0, if you don't remember this table, here it is. Alright, now the first value, when n is 0, is just the function of cosine of x, and at 0, it equals 1. And then x to the 0 over 0 factorial, so we will get 1, just 1, because everything else is 0. Now, the first derivative, f to the 1 of 0, or negative sine to the x of 0, is 0, x to the 1 over 1 factorial. Now, if we keep doing this for every single derivative all the way to the 8th, we will get this. And if we simplify, we will get this. And this can be written with the general term of this. And then put this in sigma notation, and we will get this. So wait. You might be asking yourself, I thought we were turning cosine of x into a function so that we could graph it. Well, we are. We have to go through this elongated process to find this, because this equals cosine of x. Now, to show you what I mean, let's take this, which has the graph of cosine of x on it, and this, the first 3 partial sums of cosine of x as a function. And I'll show you how, once it approaches infinity, it is cosine of x. So the first partial sum of f of x equals 1, well, that's just a straight line across like that. Now, the next part, f of x equals 1 minus x squared over 2 factorial, looks a little bit like that, an upside down parabolic shape. Now, if we do the next partial sum of 1 minus x squared over 2 plus x to the 4th over 4 factorial, we will get this. If my marker doesn't run out of paint, that is. And as we continue adding partial sums, it will continue to form around cosine of x until once we get to the infinity partial sum, then it'll be cosine of x. And after going through that entire elongated process, that's how we turn a polynomial such as cosine of x into a function that we can graph and use. Did you get all that?
Yep. First you start with cosine of x. Then you make a table of their derivatives and points of 0. Then you put those points in the Maclaurin series equation and get this series. And get this general term and this sigma notation. And that is how we get this graph of cosine.
Now you get to clean up all the mess.
Wait, what?